So to introduce you guys to this amazing, convenient technique of multiplication of complex numbers, there's something pretty basic we should go over with at first. Um, this is how you usually write a complex number, x plus I times y, and here's how you write it in a Cartesian coordinate system. This is the y-axis is imaginary axis, imaginary number axis, and the x-axis would actually be the real number axis. And yeah, here's how you actually write it in a coordinate system. Um, it also has its own length, which is r, and r, which is equal to x squared plus y squared under root. And so, okay, now stop thinking about this number in the Cartesian coordinate system. Think of it in the polar coordinate system. And as we all know, there's a way that you can write a y coordinates and a x coordinates for a point in a polar coordinate system. And here's how you write it: r times cosine theta, which is equal to the x, and y is equal to r times sine angle. And the angle here is the angle between the complex number, uh, is between the complex number and the real axis. So here's the angle. And so now you can like see some resemblance between these two expressions and the actual Euler's formula, right? Euler's formula tells us that e to the ix is equal to cosine theta plus I times sine theta. Okay, so r is missing. However, we can add the r to the equation. Multiply both sides of the equation by r, which is the length of the complex number. And you can see that um, z can also be expressed in this form: r times e to the I theta. And how do we actually calculate the theta? Theta is simply, okay, we use the inverse trigonometry here, y over x. Here's the theta. And so now you can see the convenience here. So before using this technique, you have to expand the expression, and now you don't. Let's say this is z1, the first complex number, and it has r1 and theta 1. And here's the second complex number. It has the different length, r2 times e to the I theta 2. When you multiply these two complex numbers, you simply you can simply just multiply them, and here's the result, which is actually much more convenient if you multiply a complex number in this form. You will have four terms, and it's gonna be pretty complicated relatively to this method, you know. And you can see that it also has some geometric meaning in it. When the first complex number is multiplied with the second one, it has its length increased by the factor of r2, and it also rotates around the origin. Its original angle between itself and the real axis is theta 1, and after the multiplication, it actually rotates. It's theta 1 plus theta 2 now. And overall, in summary, it is a really convenient technique, and gives you some more in, gives you a more intuitive way of multiplication of complex numbers. Thank you for watching this video. If you like it, please subscribe and give me a like maybe.